from there. So you could, huh? Yes, you go there to the back. You will see the girls one is, just keep it clean for me though. Okay. Okay. Time we were looking at expectation, and I mentioned to you that expectation is also known as the mean. Okay, so the expectation mu. And we also call it EX. And the formula for expectation is the summation of all x, the probability that the discrete random variable big X equals small x. We did several examples. This was one of the examples that we did the last example to find the expected number of heads when two fair coins are tossed. Now, remember how we got the probability distribution is that we mentioned since the random variable in this case was heads, find the expected number of heads. When two fair coins are tossed, we could get 0, 1, or 2 heads. And we already went through that. And basically the expectation is whereby you take the small values of x and multiply it to its respective probability. Okay? And then we add them up, and that will be the expectation. Now let's look at another problem here. Okay, let's look at this problem here. Okay, let's look at this question. It said that in a game, a player rolls 2 balls down an inclined plane so that each ball finally settles in one of the 5 slots, and the scores the number of points allotted to that slot as shown in the diagram below. Now, it's saying here that it is possible for both balls to settle in one slot, and it may be assumed that each slot is equally likely to accept either ball. The player's score is the sum of the points scored by each ball. Draw up a table showing all the possible scores and the probability of each. If the player plays 10 pence for each game and receives back a number of pence equal to his scores, calculate the player's expected gain or loss for 50 games. Now, how would we go about attempting this problem? It said in a game, a player rolled 2 balls down an inclined plane. Okay? And remember, it mentioned that it can settle in the same slot. The ball can settle in the same slot. So, what scores can be obtained?
On 7, sir?
He said, remember, there are 2 balls and these are slots. So if a ball drops in this 7, if both balls drops within the 7, then we're gonna get a score of 14. If a ball drop in 4 and 7, we get a score of 11. If we drop in 2 twos, we can get a 4, and so on. So it's the sum, the score is the number, okay, it will be the slot in which the ball will fall into. Are we clear with that?
Yes, sir.
Yes.
Now, the first thing we need to do is to look at our table. But before we can do our table, what would be the easiest way to do this problem?
Set it in order, sir?
Sir, wouldn't it be drawing a tree diagram, sir?
Well, not necessarily. It will be almost the same thing that we started off with. Let me see something here. Oh. That's not the one that I want to have look at. So let me get rid of this and insert table 7. Okay, let's look at this side here. We have plane 2. For 7, 1, 2. And here we're gonna have I should have bring it down. And then over here, we could have the other one, which is 2, 4, because remember it's 2 balls, right? 7, 4, and 2. So I can call this the first, it doesn't matter, the first ball. First ball. And over here, down here, I can call it the second ball. So how do we call this? What we are doing here? If you can recall. So if we get a 2 and a 2, that will be 4.
Like a frequency table, sir?
Yes, this is known as a what? Possibility
Diagram.
Is the red there, the black is there. So when we have a 2 and a 2, that give us 4. Then this will give us a, what sum will that give us?
8, sir.
2 and 4, remember it's the score of the 2 balls, the inclined.
6, sir.
So this will be 6. This will be
9.
9. This will be a
6
score
again,
of
sir.
6. And this will be
And
a
4.
score of 4. Then in the case of this 4, 4 and 2, that will be 6. Right? And then 4 and 4, 8. Then this will be 4 and 7, 11. And this one will be 4 and 4, 8. And this will be 4 and 2, 6. So what will go here?
9.
Okay, that we have 9, then
11.
11. After 11, we're gonna have
14.
14, then
11.
11, and then
9.
9. Then here we're gonna be having the same thing like this here, isn't that so? 6.
You can copy and paste it.
Yes, yeah, but I will just put it in. So that will be 6, 8, 11, 8, and 6. And this one will be just like the one to the top, which will be 4, 6, 9, 6, and 4. So what will be our possibility space here? What will be a possibility space? Or possibility space? What will it be?
Wouldn't it be 25, sir?
Exactly. The possibility space will be 25. So PS is equals to, not PS, but is equal to 25 should be N. Like that. Now we can do our table from this. So So in here, we're gonna have our X values. And then in here, this will be the probability big X equals small x. So that's what we... Now, what will be the possible scores that we can get? What are the possible scores you notice? Get 4. What is the other score?
6,
We can get 6. We can get
8,
8. We can get
9,
9,
11,
11,
and 14.
and 14. Those are all the possible scores, right? Everybody agrees?
Yes, sir. Yes, sir.
Now, how many 4s are here out of 25?
4, sir.
Is it 5?
Okay, let us see how many 4. We have 1 here, we have 2 here. We have 4. So it's 4 out of 25. Right? Everybody agrees?
Yes, sir.
Okay, let me copy and paste. We're gonna see copy, paste, copy, and paste. Copy, paste, copy. So how many 6 will they have here? Let's see the first one. We have
8, sir.
1.
8.
Okay, we have 1, 2, 4, right? 5, 6, 7, 8. How many 8s do we have?
4.
4, sir.
4. I'm just taking your words now. How many 9?
4.
4, sir.
4. How many 11?
4.
4,
Four,
sir.
okay, let me see. Yes, 4 11s. And how many 14s?
1.
1,
One.
sir.
Okay, if you were to add all the values to the top, you should get 25. So 1, 2, 3, 4, 4, 16, and 8, 24 plus 1, 25. So that would have been our table. Everybody get that?
Yes.
Yes, sir.
Now they're asking us the question, it said here, it is possible for both balls to settle. We have already seen this. And it may be assumed that each lot is equally likely to accept either ball. The player scores is the sum of the points. We have done that. Showing all the possible scores and the probability of each. That was the last thing that we just did. Now the last problem is asking here, if the player plays 10 pence for each game and receive back a number of pence equals to his score, calculate the player's expected gain or loss for 50 games. So how would we do this? So remember what we have here, this probability distribution table. If you were to find the expectation, that would be the expectation for one game. Are you getting that?
Yes.
So let's find the expectation here. Let me just copy the formula. I need to have wait towards recovering. Let me give him a little break here. So it's not responding right now. Hello, can you still hear me?
Yes, sir. We can.
Okay,
Yes,
let
sir.
me see. I'm just waiting for, because I went and I clicked so many times. Now, let me see something. Not responding. Okay, what I will do simply here, I will restart it and come back to you. Right now, just give me a break. Yeah. Online right now, students. I'll call them back. Okay. So let me see if I have the last. Oh, this. Let me see. I don't know where they. I don't think that's the one here. Okay, this is the one. So I'm gonna be saving this. And I'm gonna close that. Can you still hear me?
Yes,
Hello?
yes, sir.
Yes, sir.
Okay, let's continue then. So remember we were at the, here I told you that we expected value for one game. So let's do that. I don't know why this thing is turning and turning like, um, let me close some things here. It's working. Let me close this book. Give me a chance here. Okay, let's look at it here because we can still see. So let me see if it will copy now. Okay. Okay, so we're gonna be finding expectation here. Yeah, I'm gonna use this one. Now coming here, we're gonna have 4 times, so this will be 4 times 4 over 25. And then this will be 6 over 25. This here will be 8 times 4 out of 25. The other one would be 9 times 4 out of 25. And the other will be 11 times 4 out of 25. So the other one will be 14 and 1 over 25. So the expectation, to make it very easy, let's only multiply the top and keep the denominator. We won't simplify, just multiply the top. So this will become so this will become 16 out of 25. This one will become
32 out of
68.
25. 32 out of 25.
68.
Out of 25, sir.
38.
Sorry.
And then, okay, you are talking about this one, which will be 8 4 32. And the other one will be
36, sir.
36. This will be
4.
44. And this will be 14. Now what I want you to do is to adopt all all the numerators, 16 plus 48, and then the so what will that be over 25?
Sir, I get 190.
190?
Yes.
Okay. Now divide that by 190 by 25. What you get?
Sir, I get 7.6.
How much?
7.6.
Yes, sir, I got
Okay.
that.
Yeah, so that will be 7.6. 7.6. And because we're doing money, this should be pound. Well, let me see what's money that they use here. Okay. So they use pence. Is that if the player play 10 pence for each game, you want to find the expected loss or expected game. If you play 50 games, you have found the expectation here, which was for one game, in this case. So we're gonna be taking the 760 and we're gonna multiply that times what? How many games did he play?
50. They made 50. Oh, no.
Okay, 50 games. So we're gonna multiply that by 50. And that will give us how much that will give us?
380, sir.
380, right?
Yes, sir.
Everybody agree to that? 380. Now, this is what he would have earned when playing the game. But remember, he paid 10 pence. So we're going to be multiplying 50 by 10. So our next thing here, we're going to be multiplying so this is the original that he would have paid. So that would be 10 pence times 50, which will give me 500. So you could clearly see, did he make a gain or loss? If this is what he made on the game, on the 50 games, while paying 10 cents for each game, and this is what he lost. I mean, this is what he spent. So what will be, so we need to subtract, and then we're gonna say, so when we subtract 500 from, we subtract
120, sir.
500 minus 380 give us what you said?
120.
120 pence. Right?
Sir,
So that will be a what?
A loss.
a loss. So you write right? He lost 120 pence. Or we could have converted that to pounds, 1.20 pounds. Okay? Is that clear? So he lost. Because the problem was asking you here, if the player played 10 pence for each game and received back a number of pence equal to his score, calculate the player expected gain or loss. So he lost. That was 120 pence. Are there any questions?
So he paid 7.60 per one.
This was his expected, yes. Was his expected gain or loss. We don't know what it was, right? For one game. That was the expectation that we found here. That's for one game. But he played 50 games. So if this was the expected gain or loss, but in this case, we know it is a loss afterwards at the end, but this would be the expected amount he would have received for each game. So he paid 50, so that would have been 50 times 7.60 pence, and per so which means then for 50 games, when you take that product, you would obtain 280 pence. So that would have been his expected gain or loss. Expected gain or loss. Because we don't know what it was. Now we know that the person paid 10 pence for each game. You pay 10 pence for each game. So that would be 10 times 50, which is 500 pence. So when we subtract 380 from 500, we're going to get 120 pence. So that would be his loss. Because if this is what he paid for the 50 game, because 10 pence for each game, and this is what he earned after the 50 game, so definitely this is a loss of 120 pence. Are there any questions?
No, sir. It's just comprehension that understanding.
Yeah. You got it now, right?
Yes, though. Thank you very much.
Okay, so like I said, when you have things like these, do a possibility space diagram. You understand? Like this, and then from there you can do there are cases like what some of you mentioned, that you need to use a probability tree. There are times you could use a probability tree to fill out these, but those are certain instances or cases that you will need to do that. Anybody has any other questions pertaining to this question? You see, this is an examination, Cambridge additional. This is an examination question. Like I said, they are not difficult, but you just need to put in a little bit of thought. So there are no questions. So everything is crystal clear.
Sir, it is not difficult when we are doing it with you, sir. But when we are doing it alone, it's kind of tricky, sir.
Okay, I understand. Okay, since there are no questions, so our class has come to an end. And I'll be uploading this information. They have other information that I need to upload under the respective topic for you to practice, and I need to give you some more work to do.
Sir,
Yes.
Sir, can you scroll back to the possibility space bar? Sir, where you have the second ball, wouldn't the first ball go there since it's just one ball?
No, it doesn't matter.
Or we're just sitting it right there?
you have it. It's a possibility space diagram, and even if you have the first or second, it doesn't matter. Because at the end of the day, you're gonna still get the same outcome. The same thing if you're doing 2 die or 2 coins, it doesn't matter where they go. Long as you have the proper numbers that fit with them, but in this case, both of them are the same. The same thing with a die, 2 die, they have 6. Now, if it comes to, and it doesn't matter because it could be a tetrahedral with an ordinary die, one with 4 faces. Just have to, it doesn't matter. You just give it a label. But I know what you're saying. When it comes numerically, we would have put 1 first, but it doesn't matter.
Thank you, sir.
Okay. And if you do not like that, we could change this. It isn't hard. It doesn't matter first. Second. So let everyone be happy. Okay?
Okay.
Like that. But it doesn't matter. Well, have a nice day.
Thank you, sir. Likewise.
Okay.
Bye, sir.
Okay, bye, sir.